Okay, so last week we talked about normal distribution, okay? So whenever we're given information about the normal distribution, it's telling us that we have a mean of 18 and a standard deviation of 4, okay? So we're going to draw this lovely curve, okay? And in the middle is going to be your mean. And then you're going to take the standard deviation, which was 4, and we're going to add 4 to 18, okay? So that's going to give us 22. And we're going to repeat that process again, which is going to give us 26. And then we're going to repeat that process one more time, which is going to give us 30. And on the left side, we're going to subtract our standard deviation, which is going to give us 14, 10, and 6. And these percentages that are going to be the same each time. So for instance, within one standard deviation, it's going to be 34%. Okay, one standard deviation away from the mean. Okay, so we always want to start in the middle and then we move our way out. Okay, 2 standard deviations away in that little section is going to be 13.5%. 13.5%. Okay, 3 standard deviations away is going to be 2.35%. 2.35%. Okay, and then outside of that is going to have 0.15. 0.15. Okay, now if you added all of those numbers up that are in the different colors, okay, you would get 100%, or that's going to equal 1, right? So now we're going to actually look at this part, okay? So less than 10. So we're going to start at 10 and go to the left. So we're going to take 2.35 plus 0.15 to figure out the total percentage. Okay, so 2.35 plus 0.15 is going to give us 2.5. Between 6 and 30, that means between here to here, what we're going to do is we're going to add up 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, which is going to give us 95%. I'm sorry. No, that should be 1. And I'm just going to show it to you just because. So we got 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35 equals 99. Okay, so that's going to be 99%. Coming in here, it's going to be 99%. So this is going to be connect to 8. Okay, between 10 and 14, 10 and 14, that's 13.5%. Between 10 and 18, that's going to be 34 plus 13.5, which is going to be 47.5%. Between 10 and 26, we're going to add up 34 plus 34 plus 13.5 plus 13.5, which is going to give us 95%. And then 14 to 22 is going to give us 68%. And 18 to 22 is going to give us 34%. And greater than 22, that means that we're going to start at 22 and go to the right. So that's going to be 13.5 plus 2.35 plus 0.15, which is going to give us 16%. I'm going to go around the outside. Okay, so the numbers underneath the normal distribution are not going to change. Now, let's say that we wanted to figure out how big the percentage was between 17, which would fall in here, to 21. Okay, last week we estimated this, but this week we're going to actually find the approximate percentage. Okay, so like we're going to get a little bit closer to that actual true number. Okay, so we're going to go ahead and move down. All right, so z-score represents the number of standard deviations a random variable falls from the mean. To transform a random variable to a z-score, you're going to use the following. Okay, so we're going to take our value minus our mean divided by the standard deviation. Now, you're normally not going to see it written like this. You'll see it more written like this. This is x minus mu divided by sigma. And those are Greek letters, so you probably want to know those. Okay, what does a z-score actually tell you? It tells you how far a point estimate is from the mean. Okay, so if we say like 1 standard deviation away from something, that has a z-score of 1. Okay, so let's say that it has a standard deviation or a z-score of 1.5, then it has a standard deviation of 1.5. And it's kind of like, why not just use those terminology? But you know, mathematicians try to be trifling and confuse people. Okay, z-scores are just going to help us find those in-between numbers, essentially. So normal distributions are really easy if they're really clear numbers, but if they don't fall within those like normal distributions, this is what we're going to have to do. Okay. All right, so coming down to this example 1. It says the mean speed of a vehicle along a stretch of highway is 56 miles per hour with a standard deviation of 4. You measure the speed of 3 cars traveling along the stretch of the highway, 62, 47, and 56. Find the z-score that corresponds to each speed, and then interpret the z-score in context. Okay, so let's first just use the formula that we're given. Okay, so our formula is we're going to take a point, we're going to subtract the mean, and we're going to divide it by the standard deviation, right? This is how we find z-score. So we're going to take our point, which is 62, subtract our mean, which is 56, and divide it by our standard deviation, which is 4. So when we come in here, we go 62 minus 56 divided by 4, which is going to give us 1.5. So this has a z-score of 1.5. So just to show you what this would look like, let's just draw the normal distribution really quick. So we've got the normal curve, we've got a mean of 56, the next one over would be 60, and the next one over would be 64. And so as you can see, 62 would be 1 standard deviation and a half away from the mean. Okay, now these numbers aren't always so pretty. They're not just very, very clear. Sometimes they're a little obscure. But the z-score just tells us the standard deviation. But let's say that we wanted to find the percentage of people, which we're going to talk about in just a second. We're going to use something called a z-score table. And I'll tell you how to read those in just a second. But we're just going to use that, just going to calculate the z-score. So go ahead and take a moment and try B on your own. All right, so on B, you should have got negative 2.25. And yes, it's okay to get a negative z-score, because what that means is you're going to the left of the mean, right? Okay, so like 47 would be chilling down here, right? Okay, so it would be to the left of the mean, right? On the next one, when you calculate this z-score, you're going to get 56 minus 56 divided by 4. Well, 56 divided by minus 56 is going to be 0. 0 divided by 4 is 0. Well, how far away is 56 from 56? 0 standard deviations, right? Okay. All right, so on these problems, we're trying to find what x is. So we're going to go ahead and plug in the information that we know. Okay, so we know that our z is 1.96. We don't know what our x is. We know that our mean is 56, and we know our standard deviation is 4. So in order to solve for x, I'm going to multiply by 4 and then add 56 to it. Okay, so I'm going to multiply by 4 and then add 56. So I'm going to go into my calculator. And I don't have one filled up. No. And so I'm going to do 4 times 1.96 and then add 56 to it. And that's going to give me 63.84. This is going to be roughly about 64. Okay. So go ahead and try B and C really quick. Okay, so the first thing that you're going to do is multiply by 4 on this one and then add 56 to it. Make sure that you include that negative because it does change your answer otherwise. Okay, so you're going to get positive 46.68. Over here, if you multiply by 4 and then add 56 to it, you're going to get 56. Okay, we also know that 0 standard deviations away from the mean is going to be the mean, which is 56. Okay. All right, so what I'd like for you to do is go ahead and take a look at this independent practice down at the bottom. Okay. A lot of this is answer the question and then explanation. Okay, so go ahead and take a moment. You're reading those over, and then we'll talk about it in just 1 second. Okay, so for each of these, you're kind of figuring out whether it's kind of likely to happen or not likely to happen. So it's more likely to happen if it's within like 1 to 2 standard deviations away from the mean. If it's more than that, then probably less likely to happen. So for instance, on this first one, you would have a mean of 800, okay, and then a standard deviation of 120, right? So we would have 920, 1040, okay, and then 1160, okay, 1, 2, 3, probably one more, 20, 1280. Okay, so they counted 1243. The likelihood of that happening is about in like the top like 0.15%. So not super likely because it's probably only going to be about 0.15% chance, right? Or I'm sorry, 1.5% chance. Kind of move that decimal place. Nobody corrected me on that. So that 0.15, right? Okay, the weight of a house cat is normally distributed with a mean of 10 and a standard deviation of 2.1. Okay, so we find the standard deviation, and then there's a cat that weighs 6 pounds. So we're trying to figure out if that's likely to happen or not. So if we take 10 and we subtract 2.1, that's going to give us 7.9. If we subtract 2.1, that's going to give us like 5.8. So that's going to fall somewhere in here, which is probably going to happen, right? Okay, so you're just kind of grouping these by based off of the normal distribution curve. So you probably want to draw the curve for all of them and then order them from there. Okay, now we can sit here and go through it, but I'm probably just going to post the answer key and give you a little bit of time to do it. Okay.